Hi everyone, welcome back. In this particular video, we will be discussing the problem named as binary tree level order traversal. We are given a binary tree. What do you mean by given a binary tree? Given a binary tree means in the parameter there will be the root node of the binary tree given to us. So tree node root is given to us. We have to return the level order traversal of its node values. We have to do a level order traversal. That is, we have to print all the node values of the tree in some particular order, and that order is level by level, top to down, left to right. That is left to right, level by level. We will print and we have to return it into a list of list. As you can see on the right hand side, we have to return it in a list of list, and you can also see it from the sample output. So let's read the complete problem statement. Note that input and output are being handled by main method behind the scenes. You do not have to implement the main method or any input or output here. The inputs are sent as arguments to the function you have to implement. That is, we do not have to make the binary tree. We do not have to create it. It is already created and given to us. And also, we do not need to print the output. We only have to return it. All the necessary code should be within the function. We have to complete the function, and we do not have to change the main method. Main method will be there behind the scenes. It is not visible to us, but we have to not change it. Okay, very good. What we have to do is we have to implement the function as told by using the parameters or the arguments as input and returning the answer as the output of the function. The structure of the tree is given to you as a reference, although we do not have to make modifications in the code stub in the structure also. That is, structure is already given. A root node having left child, right child, node having left child, right child. And if any of the childs will be not there, then it will be represented using null value or null node. So input format, as we know, there will be some representation of a tree, array like representation, but we do not have to care about the input. We have to just simply say that input will be a tree where n nodes will be there, and n can be at minimum 1. That is, at least there will be one node, and at max 10 raised power 5. Maximum number of nodes in the tree will be 10 raised power 5. And the values in the nodes will be from 1 to 10 raised power 9. That is, all the values will be 32-bit integer. Output format, we have to print each level of the tree, of the binary tree, in a new line. That is, we have to do level order traversal line wise. Every level should be printed in different line. For this particular tree, 4, then next level 3,2, then next level 1, and each level should be printed from left to right. See, if we take the second tree, first level only 5, second level 5,2, third level 4,5. So let's take a tree which maybe have some more number of nodes. So what we are saying is, let's have 10, let's have 20, then let's have 30, let's have 40, 50, maybe let's take 70 here, or maybe let's take 60 here actually. Then let's take 70, let's take 80, let's take 90 and 100. And how are these nodes related to each other? 10's left child is 20, 10's right child is 30. I am creating such a tree which should cover all the cases. What are all the cases? A node having both left child and right child, like 10, 20, and also some nodes only having the left child. Example is, you can say, maybe let's take an example of any one node which can have only left child. Let's actually make 40 have only left child, and 50 will have both the left child and right child. Let's say 80 and 85. And what about 60? 60 also have both the childs, but the 30 node is only having right child. 40 node is only having left child. And all of these nodes which you can see, they do not have any of the children. That is, they are the leaf node. They have both the left child and the right child as null. So it is not necessary that all the leaves will be on the same level, but this is one of the tree which is given as an input. And what we have to do for it, we have to print the tree level by level, left to right, top to down. That is, first level should contain 10. In a list, I have to store 10 and return the list. In the second list, I have to store 20, 30. Go level by level, left to right. Then in the next level, I should have 40, 50, as well as a 60. Then in the last level, what should I do? I should have 70, 80, 85, 90, 100. Although the nodes which I have taken are in sorted order, but it is not necessary. It will always be like this particular ordering. It depends on how we are creating the binary tree or what is the input binary tree given to us. We have to store all of these levels into a 2D list and return that 2D list altogether as a return type. So what should be the approach? See, if you have learned about DFS traversal, if you have learned about the depth firsters, or you can say the pre-order, in-order, post-order traversal. In those approaches, what we did, we used recursion to solve them. That is, we went to the depth at max depth as possible, because from 10, we should go to 20, then 40, then 70, then explore the second branch, then third branch, then fourth branch, then fifth branch. But now in level order, what we have to do? First, we have to explore all the nodes in the first level, then all the nodes in the next level, then all the nodes in the next level. That is, first we have to travel all the nodes which the root is able to visit, then all the nodes which 20 is able to visit, then all the nodes which 30 is able to visit, then 40, then 50, then 60, and then you can say all the leaf nodes finally. So if we have to go level by level, what data structure should I use? In recursion, we are using recursion call stack. That is the first in last out policy, LIFO policy or FILO policy. The node which is first inserted is last popped out. But when it comes to level order, we will be using queue data structure, or you can say a data structure following FIFO policy. Why we need FIFO policy? Why we need first in, first out? If I am going to say first insert 10, then first 10 should be visited because in the first level 10 is there. In next level, 20 and 30 both should be visited one after the other. That is, both the children of 10 should be visited in next level. Now, when it comes to 20, if we are saying next children or the next level nodes for 20 will be 40 and 50. Before 40 and 50, we should visit 30 because we have to visit first level, then second level, then third level. If we need 40 to be visited after 30, or you can say 30 to be visited before 40, then we need the first element which was inserted to be first removed also, that is first visited also. Whatever element we will remove from data structure, we can assume it is visited. So if we are pushing first 10, it is first visited, then 20, second visited, then 30, fourth visited. We are pushing both the children. Then when we will say visit 20, that is pop 20, we will visit both the children of 20, that is 40 and 50. So this will be the fourth node getting visited, fifth node getting visited, and so on. So since we need the node which is getting inserted first to be popped out first, to be visited first, we need first in, first out policy, which can only be governed by queue data structure. Anyways, let's have a queue and let's do what? Let's try to do the level order traversal, but we have to make sure that we are doing it level by level. Since we are doing it level by level, we need to make sure that how many nodes are in the current level. So initially, obviously, we have to start the traversal from some particular node, because if the queue will be empty, the traversal will not start at all. So what we have to do, we have to start the traversal from the root node. That is pretty obvious. So what we can do is we can push the root node itself directly into the queue. And we have to make a queue of node and not of integers. Why of node? Because we have to go to the left subtree or the right subtree. But if we are pushing integers, we can't get the left subtree or the right subtree. So that's why we have to push the entire node itself. I am representing node using circle. So first we push 10 and now we will be starting the traversal. We are asking how many nodes are in the current queue. There is only one node. So let's just have an imaginary partition. Initially all the list will be empty. So what we will do is we will create a new list where we are going to insert all the nodes in the current level. So since currently the size of queue is 1, we will pop one node from the queue because there is only one node and add it in the array list, that is added in the, you can say, dynamic array. So one node in the first level, which is 10. Now, since we were able to pop one node, in the next level, we will be pushing its child, because if a node is at level X, the children of that node will be level X plus 1. So we will push them into the queue data structure, because queue is what is going to help me to print the nodes in level order. So I will first push the left child, then right child. Why? Because I want the traversal from left to right. So I want 20 to be pushed first, because first in, first out, then 30 to be pushed. Now, since first level is done, now we will be going to second level. So for second level, we will create a new list, because we want all levels in different lists. And we will figure out what is the size of queue. It is 2. So we will pop for 2 times. We will visit two nodes in the current level. What are those two nodes? First node is 20. Add 20 in the list, the 1D list. That is the second level. And for the nodes which are the left child and right child of 20, we will push them into the queue because they should be visited in the next level. So I will push 40, I will push 50 into the queue. But size obviously will change of the queue, but we have to make sure that the size variable for which we are running the loop should not change, because first time we were running loop only for one time, then two times, then next time we will run it for more times depending on number of nodes. So we do not have to make this size variable also get changed. So we will make the size variable get fixed. Okay. So we have pushed first node of the second level, and now we will be pushing second node of the popping the second node of the second level, which is 30. So visit 30. After visiting 30, in the next level, the 30 children should be visited. So we should push them into the queue. Only right child is there, so we will only push right child. If there is no left child, no need to push null node, because null node is anyways an empty tree. So we can't just push empty trees into the queue. So in the next level, what we can see is the queue is having three number of nodes. That is size is 3. So next level will be having 3 nodes. So we can create a list which will be growing dynamically, a dynamic array or a dynamic list, which will have 3 nodes. First node will be 40, and all the children of 40 will be pushed into the next level, or imaginary next level into the queue. So that is 70, only left child is there, no right child is there. Then second node in the third level will be 50. So we will add 50. Same thing. Since both the children will be on next level, this is level 3, this should be level 4. So we will push them into the queue to get visited as a part of next level. What about the third node of third level, which is 60? I will add it in the list, and I will say both the children of 60 should get visited as a part of next level. Let's for now ignore both of these nodes, otherwise dry run will go very large. So finally, again, in the last level, there are 3 nodes only. So what we will say, just run a loop for 3 times because size is 3. So make a list which will have 3 elements in the last. First, pop 70, add 17 into the list. There are no children for 70, neither left child nor right child, both are null actually. So we will not push null children. Similarly, for 80, we will add it in the list, but no children are there. And same goes for 85. We will add it in the list, but no children are there. And finally, once the queue becomes empty again, then we can say we have done the entire traversal. And all of these 1D lists are inside a 2D list, which we can return. That is, we are able to do level order traversal line wise, level by level, by using a queue data structure, by using FIFO policy. So I hope the approach is clear to everyone. But before going to the instruction manual, we should discuss what is the time complexity associated with this approach. Since we are going to push every node once into a queue data structure, and in all programming languages, if you are using queue, which is implemented either using a double-ended queue or a linked list, the insertion time in queue is usually constant for single insertion, and removal time is also constant for single removal. How many nodes are getting inserted in queue? Not tree number of nodes, n number of nodes are getting inserted, whatever total nodes are in tree. So n insertions, so linear time plus n removals, again linear. So 2 times linear time, which is still linear in nature. 2n is still n in bigger time complexity. So time complexity will be linear. What about space complexity? Since we are using a queue data structure, which at any point of time can have 2 nodes or 2 levels, or maybe you can say at most whatever nodes can be there in 2 consecutive levels, and in one level there can be at most n nodes. Usually if there is a complete binary tree kind of thing, then we will have 4 nodes in this level, and total there will be 7 nodes. So 4 is almost 7 by 2. So we can say space complexity in worst case will go linear only, because of the queue data structure. We are taking extra space complexity, extra auxiliary data structure. So time and space both will be linear. Let's now jump on to the third milestone, which is nothing but writing the instruction manual, the corresponding instruction manual. So what we have to do, we have to create a queue of nodes, create a queue of containing what? Containing nodes, that is 3 nodes. And let's say the queue name is queue only. Whatever language you are choosing, most probably you will have an inbuilt function or an inbuilt data structure which you can use to make queue. If not, then you can make a queue on your own also. Anyways, after creating a queue, the second thing which we need is we have to push the root node if it is not null. And in the question, in the constraint, it was mentioned that at least there will be one node. So even if you do not check that the root is not null, still it is going to be okay, because root will never be null according to the constraints. So we can just simply push the root node, because if we are going to push null node, we can't say null dot data, we can't say null dot left subtree, null dot right subtree. So we have to push, or you can say add the root node in the queue. After pushing the root node, now the traversal will start. But before actually starting the traversal, what we have to do? We have to maintain a 2D array list. So create a 2D array list. Create a 2D list of integers, which will store all the levels. So let's say this 2D list is named as levels only. 2D list of integers named as levels. Now we can start the iteration. Now we can start the traversal. So run a while loop till which point? What was the ending point? When the entire queue becomes empty, we have to stop. So we have to run the while loop till queue size is more than 0. We have to run. And within this loop, we have to not just simply pop nodes and push nodes. We have to pop them according to the number of nodes in the current level. That is, we have to run a loop according to whatever the current size is of the queue. So we have to figure out the size of queue, store size of queue or number of nodes in queue in a variable, and then run a loop for that many times. Now run a loop for size number of times. So once we are running a loop for size number of times, now we will say just pop the front node, pop the node from queue, pop a node. Let's say the node name is current from queue. And obviously we have to add it in a 1DR list. But where do we have to create 1DR list? Before we are starting the current level, we have to create a new array list. Once we were pushing 10, we were having new array list. When we were pushing 20, a new array list. When we were pushing 40, new array list. Whenever we are pushing the first node of every level, we have to create a new array list. That is, before starting the loop, create a 1D array list also. So inside this outer loop, or before this inner loop, we have to create a 1D list. And since 2D list was named as levels, we will say 1D list is named as level, a single level. So pop the node and push, or you can say add the nodes data into the list, level list, into the level 1D list. Once we have added the nodes data into the 1D list, now we can push both the left child and the right child. What we did? First we visited 10. Visited 10 means add in the array list or the dynamic array. And then push the left child and the right child into the queue if they are not null. So if the current's left node, left child is not null, then push it into the queue. Then push current's left into the queue, left child in queue. And same goes for right child. So I will have same thing. If current's right child is not null, then push current's right child into the queue. If both are null, do not push both of them. If only left child is there, only push left child. If only right child is there, only push right child. If both childs are not null, then push both of them. So pop the node, add it in the list, and then push both the children. Once this entire loop is done, now we are sure that we have added, or we have created the current level. We have added all the nodes in the current level, and whatever the current 1D list will be, 1D list, all these 1D lists are there. First level, second level, third level, fourth level. All these levels are lists, we will add it into the global list, that is 2D list. So after the loop is done, we will add the 1D list that is named as level into 2D list, which is named as levels. We will add the current level into the levels, that is list of list. And once this entire loop is done, we are sure that we are done with the traversal. We are done with the entire tree traversal in level order, or you can say BFS, breadth first traversal, because we are going breadth wise, level wise. And finally, we can of course return the 2D list, return the 2D list levels. So this should be the code. If there will be some corner cases missing, then we can handle them during the code time only, when we will write it. We'll actually write the code from it. But this is a self-explanatory pseudocode which you can use to actually do the inline expansion. First of all, what we have to do, we have to create a queue containing nodes. So how can we create a queue of nodes in Java? We can say in the left-hand side queue is an interface in Java of type tree node. Queue is equals to new. Maybe you can have an object of array queue or you can have an object of linked list. It is your wish. I will be using array queue. So this is creating an empty queue in Java. Actually, we are just creating a DQ, but pointing it as a queue. But nevertheless, once we have created a queue, we have to add the root node in it. So queue.add root node directly. And we are sure actually right now that will not be null. So we can add it directly without checking whether root is not null because at least there was one node in the tree. Now we have to do what? We have to create 2D levels. So for now, let's just ignore the 2D list part. That is what we have to return. For now, let's just return null or maybe return a empty array list. And we will figure out how we can just maintain the 2D list. Let's just have the traversal for now and we will just see what is the output by printing it directly. So we will run a while loop and what we will say, we have to run it for all levels. So outer loop will run level by level for all levels. And inside the outer loop, what we have to do? We have to run an inner loop for the current level for that many times, whatever is the number of nodes into the queue. So we have to, first of all, store the size of the current queue, which can be extracted using queue.size, and now run a loop for that many number of times only. So for int index is equals to 1, index is less than equal to size, index plus plus, that is running a loop for size number of times. And once we are running a loop for size number of times, what we have to do is pop the current node from the queue. So let's just simply say what? We are having the current node. So tree node, because it is a tree node only, current is equals to queue.remove. Remove is the function to pop a node from queue in Java. Once we have removed a node from queue, what we can do is we can add it in the list. But since right now we are not making list, let's just print it. So system.out.print current's value, the current's data, that is val variable, current.val. And let's just add a space so that all the outputs are having space in between them. Then let's just run this much code and see what is happening right now. If it is giving me the first node itself, because I have not pushed the child nodes, so it should be able to give me only the root node as output. Yes, if the root node is 4, it is giving me only one output, which is 4. But now let's do what? Let's add the children also. So if the left child exists, that is, it is not null, we have to add it into the queue and we have to say queue.add current.left. Same goes for the right child. If the right child exists, only and only then we have to add it. If it is null, no need to add null node into the queue. Otherwise, queue will become very fat, like you are unnecessarily just pushing null nodes. So let's run it again and see what is happening now. It should actually print all the nodes present in the tree with spaces because we are not printing in different lines, all the levels in different lines. There is slight error with semicolon in line number 47. Let's just add semicolon and run it again and see if it is now able to print all the nodes level by level. If in the first example we see output should be 4, then 3, then 2, then 1, and output is actually 4, then 3, then 2, then 1, but all the nodes right now are getting printed in same line. What we can do is, after the inner loop, once all the nodes of a current level are printed of the inner loop, we can add a new line just to be sure that we are doing it level by level and not just simply as a single traversal, but we are doing it in multiple iterations. First iteration, first level, second iteration, second level, and so on. Yes, that is what we are getting now. First level, 4, second level, 3 and 2, third level, only 1 for the first example, sample input. Let's just also take the second sample input and see if it is going to give me the correct output or not. The output should be 5, then 5, 2, then 4, 5. Let's see if it is giving me the same output or not. So there is some error with the type of input which I am providing to it. But nevertheless, since it is working for sample input, let's just do what? Let's just create the list because we have to actually create a list and not just print. So we will be saying create a 2D list, that is list of integer, let's say levels, because it will store all the levels, all the array lists. And inside the loop, For each level, we have to create a 1D list. So list of integer, a single level list, only a level is equals to new array list. For each level, we have to create a new array list, so that we are creating it inside the loop because we want it for new level, a new array list. And what we will do, instead of just printing, we will say level dot add the current value. And instead of adding a space, we will just simply say level dot add. And instead of adding a println, we will say add the current level into the 2D level. Add the 1D list into the 2D list. Levels dot add level. And obviously in the last, we have to return the 2D levels, all the levels array list. The array list containing all levels in level order traversal. So let's see now if the output which we are getting is correct or not. Let me just remove the custom test case. Let's run it again. It should give me the output as 4, then 3, 2, then 1. Let's see. So there is some problem with long cannot be converted to integer. So why is it giving me an error? Long cannot be converted to integer at line number 45. Let's see. At line 45, we are having level.add current.val. But val is a long variable and we want to store it as an integer. So we can just do typecasting. We can just write integer in front of it because we want to store it as an integer. We have to convert a bigger data type into a smaller data type. That is, we have to do explicit typecasting in Java. So now it is working absolutely fine for sample test case. Let's also test it for some corner test cases and then we will submit. What if there is only one node having value 10 and both the left child and right child are null? -1 represents null actually in the sample input. So it should only print one level containing 10. Let's see if it is only printing 10. Yes, it is only printing 10. And what will happen if, let's say, we are having two nodes with the 10 and 20 values, and 10 having left child as 20 and 20 having both the children as -1, that is null. So it should print me first level having value 10, second level having value 20. Let's see. So expected output, actually we have given the input in some wrong fashion. Maybe we have to go through this input format, that how input is given, but let's try to submit it. And actually it is working for all test cases. So the problem was not with the code, problem was the way we were giving the input. Anyways, the code is working, but code is very big. The traversal is very complex when it comes to coding part, because we have to do it level by level and not just single level. So as you can see, since we are doing the outer loop for all levels and inner loop for a single level, will it go n square? Will it go n into n? The answer is no. It will still be linear. Reason is the total time complexity will be the number of times we are popping the nodes plus number of times we are pushing the nodes. And how many nodes are getting pushed? All the tree nodes, that is n. How many nodes are getting popped? N. So total time complexity will be n plus n, which is 2n, which is still linear in nature. And what about space complexity? Since we are using a queue, or you can say array queue, and which will require all the nodes of a current level to be pushed, it will also go linear. So both the time complexity as well as the space complexity will be linear for the problem level order traversal. I hope the code as well as the fifth milestone, that is the corner test cases, are clear to everyone. So if you have any doubts, you can reach out to us. And till then, keep coding, keep hustling.